All right, we're going to talk a little bit about the different methods that we've gone over to solve quadratics and kind of summarize each of them and talk about how we would apply each of them. So the first one is the first one we talked about, which was solving quadratics by graphing or by using tables. That was the first thing we talked about a couple weeks ago. And when we talked about it being one that can work on every problem, but also kind of a time-consuming one. We don't really want to have to graph a quadratic, and if the solutions aren't whole numbers, it becomes kind of a tedious task. So when you would want to use it, or how you would use it, you'd want to make sure the equation's equal to 0. You'd replace the 0 with a y, so that we create a quadratic that we can graph. And then we would graph it. So if you could use Desmos, you can use your graphing calculator, you can do it by hand. The AOS, remember AOS is x equals negative b over 2a. And then we're going to find the x-intercepts because those are your solutions. So we're trying to find the value of x when y is 0. So if we look at this problem, again, what we're going to do is first get everything to one side. So we're going to subtract 2x as well as add 10. So we're going to have 2x squared. We're going to subtract 2x and add 10. So we're going to have 2x squared minus 12x plus 10, and that will be 0. Again, we're basically just going to rewrite this as 2x squared minus 12x plus 10 equals y, now that it's equal to 0. So that's what we're going to graph. And so, we'll look for the axis of symmetry, which will be negative b over 2a. Our b value is negative 12. Our a value is 2. So that would be 12 over 4, or 3. So that's our AOS, x equals 3. And so that gives me kind of a starting point in my table. And I'm going to create an XY table here. And again, we are looking for the x value when the y value equals 0. So I know I've got an AOS down here at 3. And I would take 3 and I would sub it back into my equation. For x to determine what the y value is. So 3 squared is 9, so this is 2 times 9, minus 12 times 3, 36, plus 10. 2 times 9 is 18, 18 minus 36 plus 10. That's negative 18 plus 10, which is negative 8. So there's our AOS, or our vertex, I should say now. And then we'd just build this thing out. I would just keep dropping in new x values. And getting new y values. And to be honest, the easiest way to do that is to grab your graphing calculator, type in 2x squared minus 12x plus 10 into the y equals. Go second table, and we'll get values. 4 goes with negative 6, 5 goes with 0, 6 goes with 10, and if I work the other way, 2 is negative 6, 1 is 0, 0 is 10, and again, what we're looking for, as mentioned over here, x equals 0 when y is 0. X equals what? Sorry, when y is 0. So there's the two values of interest to me. So that would give us solutions at x equals 1 and x equals 5. Solving by factoring, that was the next one we talked about. And it can be a very easy one to use if the quadratic is set up to be factored. And so there's a couple things that need to be true in order for that to happen. One, the equation has to be equal to 0, or we need to set it equal to 0. And then we look for a GCF if we can factor that out. Again, these are a lot of times this is a great problem when it's x squared, and the a value is 1. That makes it a whole lot easier sometimes to factor. And again, remember, not every problem is factorable. So, you know, x squared plus 10x plus 12, you know, you think about when we're trying to factor that, I need two numbers that multiply to 12 that add to 10. My numbers would be 2 and 6, 3 and 4, 1 and 12. Again, none of those add to 10, so you can see that a problem like that isn't going to be factorable. But if this were, say, 7, and this is 7, oh, sorry, changed the wrong number. If this were 7, now we put it in 3 and 4, we got x plus 3, x plus 4 equals 0, and our solutions then were x equals negative 3 and x equals negative 4. So, and again, sometimes that is a very easy problem to solve. Let's look at one here that isn't as easy, but again is doable. So first thing I'm going to do again is subtract the 2x and add the 10 on both sides so that this thing's equal to 0. So I've got 2x squared minus 10x plus 10 equals 0. So that's the quadratic that we're solving. The first thing I notice is that I do have a greatest common factor, which is 2. So this becomes a little bit easier to factor and solve because I can factor out that 2, leaving me x squared minus 5x plus 5. Oh, whoops. Let me back up here. I forgot to subtract the 2x. So we're not negative 10. We are actually negative 12 there, which means this was 6x. So we need to factor this. I'm going to put the 5 at the top, the negative 6 at the bottom. Two numbers that multiply to 5 that add to 6 would be negative 5 and negative 1. So in factored form, this is x minus 5, x minus 1. Again, each of these we break off and we set equal to 0 to solve them. So I get x equals 5 and x equals 1. Now we talked about completing the square as another process here. Steps here, again, rearrange the equation so the constants, the numbers, are isolated. If a isn't 1, divide both sides by a. And again, there's another constraint on that problem. It may not always be nice to divide everything by the a value. Then we find that perfect, or that value that will complete the square, which is the b value divided by 2 squared. Then we factor the quadratic side, we square root both sides, adding a plus or minus, and then solve. So in this one, again, I'm going to leave this actually on the other side. I'm going to subtract 2x only. So I've got 2x squared minus 10x. I did it again. That's minus 12x equals negative 10. Again, I am going to have to divide everything by 2 to get the a value to 1. So this becomes x squared minus 6x equals -5. Again, we need to figure out what value is going to go here to complete the square. That's my b value divided by 2, and square it. -6 divided by 2 is -3. -3 squared is 9. So I'm going to go plus 9 there and plus 9 over there. That allows me to turn my left side into x minus 3 squared. The right side is -5 plus 9, which is 4. Again, the reason we did minus 3 here is because that's half of -6. I want to square root both sides here. What that allows me to do is get rid of my square on the left side, so I'm going to be x minus 3 over there. Now, square root of 4 is 2, but I got to put in a plus or minus sign in the front of that. So now I've got x minus 3 equals plus or minus 2. I'm going to add that 3 to this side, and I get x equals 3 plus or minus 2. Again, notice where the 3 went in front of that plus or minus. And that allows me to turn this into a 3 plus 2 equals 5, and a 3 minus 2, which equals 1, giving me x equals 5 and x equals 1. Last one, again, solving quadratic formula, the one we just more recently worked on. Nice thing is it works on every problem. There's really no problem that the quadratic formula doesn't work on, and it's really not any harder on any one type of problem. Biggest thing, again, set the equation equal to 0, identify the a, b, and c, and then start. So let's get this quadratic as we have. 2x squared minus 12x plus 10 equals 0. The a value is 2. The b value is -12, and the c value is 10. We're going to do negative b over 2a, which will be -12 over 2a, which is 2 times 2. Let's go -12 over 4, which is -3, which equals just +3. So there's our first part. Second part is the square root of b squared minus 4ac all over 2a. Start to substitute in our values. B is -12 minus 4 times a, which is 2, times c, which is 10, all over 2 times a, which is 2. Oh, I forgot to square that thing. -12 squared. All right, let's square -12, which is 144. Again, a negative times a negative is always positive. That will always be positive. Then I'm going to do this chunk here, which is -4 times 2 times 10. -4 times 2 is -8, and -8 times 10 is -80. All over 2 times 2, which is 4. 144 minus 80 is 64 over 4. Square root of 64 is 8 over 4, which is 2. So we take our first part, 3. We go plus or minus the second part, which was 2. 3 plus 2, whoops. 3 plus 2 is 5, and 3 minus 2 is 1. X equals 5, x equals 1. The only one we didn't have on there was solving by square roots. And that one, let me erase this really quick. Maybe. When we're solving by square roots, again, that's kind of a specific type of problem. That one, oops. You may just want to jot this one down again. That's only when no bx term. So 3x squared plus 10, for instance, or x squared plus 100. Again, that bx term isn't there, that negative 10x term isn't there. If that's there, we can't use the square root method, but if it is there, it makes it for a really, really quick problem. So hopefully that helps work through some, again, quadratic formula we can use on every problem if you get comfortable with it. Completing the square, again, really nice if the a value is 1. If it isn't 1, you've got to divide everything out. And again, that doesn't always work out nicely. Factoring is really nice, again, if the a value is 1, if it is factorable. And again, not every problem is factorable. So hope that helps a little bit as we start to practice those.